8th graders to our very first author visit. I'd like to first thank Blue Marble Bookstore for making this event possible. Today's award-winning author has written comics and graphic novels for over 15 years. I would like to personally thank Mr. Yang for writing graphic novels that I feel across many different types of genres. His book, Working Poor in Chinese, which you can find on our library shelf, was the first graphic novel to be nominated for a national book award and the first to win an American Library Association's Prince Award, and also won the Eisner Award. His 2-volume set of graphic novels, Boxers and Saints, was also nominated for a national book award and won the LA Times Book Prize. He has done a number of comics, such as DC Comics Superman, and the comic books for the popular Nickelodeon cartoon Avatar: The Last Airbender. His newest graphic novel, Secret Coders, promises to be an exciting mystery filled with logic puzzles and basic programming instruction. Please join me in welcoming Mr. Gene Yang.
Lois Lane, one of Superman's best friends, reveals to the world Superman's secret identity. So because of an article that Lois Lane writes, everyone in the world now knows Clark Kent and Superman are the same person. That's the first thing that I love, comics. The second thing that I love is coding, is computer programming. I love it so much that I majored in it in college. I went to UC Berkeley, and there I got a computer science degree. So I spent 4 years in college making computer programs. After I graduated, I got a job in Emeryville, California. It's a small town just outside of San Francisco. There I worked for a small company called VideoSoft. I was a software developer. I worked there for 2 years, so I spent 2 years making programs. Have any of you heard of Emeryville? Just a couple of you. Emeryville is really only famous for one thing. That's the home of Pixar. That's where they make all those Toy Story movies and Up and Monsters, Inc. I didn't get to work for Pixar though. I worked for VideoSoft. This was our office building. After I quit my job at VideoSoft, I took a job as a high school teacher. I taught at Bishop O'Dowd High School in Oakland, California, and I was there for 17 years. I taught a little bit of math and a little bit of art, but I taught mostly computer science. I taught mostly how to program computers. So I spent my entire adult life both making comic books and also either making programs myself or teaching kids how to make programs. For a really long time, these were actually two separate worlds for me. So for years, I would teach computer science during the day, and then I would make comics at night. And these two worlds, the worlds of comics and coding, never came together. Well, finally for me, they are. This week, my publisher, First Second Books, is releasing a book that I've been thinking about for a really long time, Secret Coders. This finally brings these two things that I love so much, comics and coding, together. Because this is a comic book that teaches people how to code, how to program. This is a joint project. I didn't draw it. It's drawn by my friend Mike. So there is cartoon Mike. He loves cats, so we put a cat on his shoulder. Mike has this really fluffy beard that I'm actually very jealous of because I can't grow a beard like that. But he is an amazingly, amazingly talented cartoonist. Before working on Secret Coders with me, he worked on this show called Bravest Warriors. Anyone heard of Bravest Warriors? A couple of you. Have any of you heard of Adventure Time? You know what that is? Okay. So the creator of Adventure Time was this guy named Pendleton Ward. Pendleton Ward actually created two shows, Adventure Time and Bravest Warriors. Bravest Warriors is a little bit more risque, so it didn't end up on network television. It's actually a web-only series. Mike did a lot of the character designs for that show. He also worked on the comic book that was based on Bravest Warriors, and he actually left his Bravest Warriors job to come work on Secret Coders with me. He has this amazing, energetic style, so I feel really, really lucky that he chose to work with me. The way Mike and I are talking about this book is we're telling people that it is a lot like Harry Potter. I'm sure you've all read Harry Potter, right? So in Harry Potter, you have a group of kids, they find the secret school teaches magic, and then they become wizards. They learn magic and become wizards. Our book is almost exactly like that. So a group of kids, they find the secret school, but the secret school, instead of teaching magic, teaches coding. They learn how to code, and they become coders. There is a problem with Harry Potter. If you've read Harry Potter, you know this problem. And that is, you read about these kids learning magic, and then when you go home, you try the same things, you don't get to be a wizard. But our book does not have that problem. You read about these kids becoming coders, you go home and you try the same things, you get to be a coder as well. Our three main characters are 3 7th graders, Hopper, Eddie, and Josh. And what I like to do is I like to base all of my characters on some real world inspiration. So each of these characters has real world inspiration. Hopper, who is the main character, she is inspired by one of the most famous programmers in the history of computer science, a woman by the name of Grace Murray Hopper. Grace Murray Hopper was a rear admiral for the United States Navy, and she fundamentally changed the way computers are coded, the way computers are programmed. I'm going to talk a little bit about what she invented later on. Now, it was really important for me to have a girl as my main character because most people don't know this, but programming started off as what was considered a woman's profession. Early on, it was mostly women who were doing the programming. In fact, the very first is that Chris Bosch isn't just a basketball player. He is also a straight-up nerd. Chris Bosch is the son of a systems analyst and an engineer. His dad was an engineer, his mom was a systems analyst. He loves math and he loves coding. When he was in high school, he was part of the National Honor Society and also part of his school's math club. He wasn't just on the varsity basketball team. When he got into college, he was planning on majoring in computer imaging and graphic design. But then he got so good at basketball that he dropped out of college and joined the NBA. But even now, with his MBA millions, he invests a lot of money into technology, into tech companies, because he loves computers so much. A lot of times people think of athletics and academics, or sports and coding, as these two separate, diametrically opposed things, but they're really not. There are plenty of people who are really good at both, people like Chris Bosch. The last main character is a spiky-haired kid named Josh. Josh starts off in the story as kind of a jerk. He's kind of mean to Hopper and Denny. And then as the story goes on, he becomes friends with them. Josh is based on a real-world jerk that I know. My brother-in-law, Louis, this is what he looks like. Now, I gotta be honest, Louis and I are pretty good friends, but he likes to make fun of me a lot, and that's why I wanted to make a character based on him. Louis is not a coder, but he loves computers. I don't know why he didn't become a coder. He's actually a surgeon. So what he does with his days is he goes to work and he opens up his patients to work on them. And then he goes home and he opens up his computer to work on it. I don't know why he loves computers so much. I don't know why he didn't just pursue that as a profession, but I gotta say, he's doing pretty well as a surgeon. He also has the pointiest nose of anybody I know. So I wanted to create a pointy-nosed character in honor of him. Secret Coders is all about computer programming, and that's actually what I want to talk to you about today. And I'm going to start with this question right here. What exactly is computer programming? There are actually two words here that I want to define. I'm going to start with the first one, computers. Now, you are all surrounded by computers. There are probably computers in every aspect of your life. And nowadays, computers come in all sorts of different shapes and sizes. So there are laptops, and there are smartphones, and there are game systems. Any other computers in your lives? Any other examples of computers in your lives? Go ahead. The iPad, yeah. The smart TVs, most modern TVs are computers. Go ahead. Yo, you're going to say that too? Okay, so there are iPads, there are smart TVs. Anyone heard of a Nest? You know what that is? It's actually a little thermostat. It sits on your wall, and it's essentially a computer that controls the temperature of your home. There's also most modern refrigerators are computers. I bet a lot of the cars that your parents are driving are also computers. So computers come in all sorts of different shapes and sizes. Well, what is it about all these machines that make them computers? What is it that ties them all together? Lots of really smart people define computers in lots of different ways. I'm going to use this definition right here. A computer is an electronic machine that does four different things. The first thing it does is it takes in data, it receives data input. It's just a fancy way of saying information. So it has to take in information in some way. The second thing it does is it stores this data. It stores information. Third, it processes this information in some way. And it does this according to a set of instructions. Processing just means it either changes the data itself or it uses that data to do some kind of calculation. And finally, it outputs data. So spits out new information at whoever's using that computer. All those machines that we just talked about, they all do these four things. Let me give you an example. Let's take a look at the laptop. So the laptop receives data input through the keyboard. When you type on that laptop, it's taking in data. It stores data by, well, whenever you're using Word, if you go to File Save, it's actually saving the data that you just input into its hard drive. And it processes data. When you push one of the buttons on your laptop, like let's say you push the A key, it has to decide what to do with that A key. So if you're using a word processor, it's going to show that A on the screen. If you're playing a game, it's going to move your character from one side of the screen to the other. That decision is an example of processing. And then it outputs data by showing you something on that screen. It'll either show you the game, if you're playing a game, it'll show you a paper, if you're typing a paper on Microsoft Word. A laptop does all four of those things. Every single computer information that's in your brain and sticking it into the Nintendo DS. How about storing? How does the Nintendo DS store data? Go ahead. That's right, stores on an SD card. So if you're halfway through a game and you want to go eat dinner and then come back, you can save your game on that SD card. How does it process data? This is the harder one. How does the Nintendo DS process data? Go ahead. Say that again. Okay, it uses chips, but what's an example of what it does when it processes? What's an example of a decision it has to make? Go ahead. Okay, good. Like interpreting your buttons into the movements of your character. So for instance, when you tell a character to move right, the Nintendo DS has to decide whether your character gets to move right. If there's a clear path, then your character does get to move right. If there's something in the way, like a wall or another character, then your character doesn't. That decision is an example of processing. And how does the Nintendo DS output data? How does it output data? Go ahead. Yep, it shows you on the screen. Nintendo DS also has speakers, so the sound in here is an example of output. And some Nintendo DSs even have that rumble feature, so when it shakes in your hand, that's an example of information being output to you. Every single computer does all four of these things. If a machine does all four of these things, then it's considered a computer. So what about that second part? What exactly is the programming part of computer programming? Well, the programming part has to do with that third step right there. When the computer processes data, it processes it according to a set of instructions. It has to follow a set of instructions to do it. Writing that set of instructions is essentially what programming is all about. So programming is just writing a list of instructions for a computer to follow. Here's a chart of exactly what a coder does. So a coder will take an idea, and then sometimes the idea is her own, sometimes the idea is something that her boss gives her, and then she'll translate that idea into a list of instructions that is meant for a computer. That's all a programmer does. There is a problem with this process, however. The problem is that the coder and the computer usually speak two different languages. So the coder usually speaks something like English or some other human language, and the computer does not. The computer usually speaks in what is essentially ones and zeros. So do you see the problem here? The problem is, what do you write that set of instructions in? What language? Well, early on in coding, early on in computer science, people used to write programs using just ones and zeros. So can you imagine that? Can you imagine typing a list of instructions and all you have are ones and zeros? 1, 1, 0, 0, 0, 1, 1. It was a terrible job. It was horrible. Then along comes Grace Hopper. Remember her? This is how she fundamentally changed the way human beings interact with computers. She created a brand new process for creating computer programs. So you still have the coder and the computer. The coder still takes an idea and translates it into a set of instructions. But this set of instructions isn't written in ones and zeros. It's actually written in English-like language. Not English, but some language that's close enough to English that a human being can actually read it. Then this list of instructions gets put through what's called a compiler or an interpreter. This is what Grace Hopper invented. A compiler or interpreter is a piece of software that can translate a list of instructions written in an English-like language into a list of instructions written in ones and zeros that a computer can understand. After she invented this, she revolutionized programming. Human beings were able to create much more complex programs because they were able to immediately understand the instructions that they were trying to write just by reading them because they were English-like. Now, so after that, everybody was happy, both the coder and the computer. Now, this is the instructions right here. The first one, the one written in the English-like language, we refer to that as source code. The second list of instructions, the one written in ones and zeros, we refer to that as object code. When you download a game from the internet, when you download a game to your phone, when you go to the store and you buy Microsoft Word off the shelf, what you are buying is object code. What you're buying is essentially ones and zeros to tell your computer what to do. The source code, any ideas how you get to the source code? Like, let's say you wanted to see the source code for Super Smash Bros. How would you go about doing that? Any ideas? Go ahead. Okay, maybe you could put a backend interpreter or compile Why? Why do you think that would be? Why do you think computer companies care so much? Go ahead. Exactly. So somebody else can't copy the idea. If you got a hold of the source code for Super Smash Brothers, you can create Super Smush Brothers, and you can compete with Nintendo. Nintendo doesn't want that. Source code is a big deal. What coders create is a really big deal. It's very valuable. If you follow the news that comes out of the computer industry, every now and then some source code will leak, and it's always a huge, huge deal. Like sometimes there's lawsuits involved, sometimes there's even jail time. Big deal. Let's talk a little bit about that other piece of code, the object code. Like I said, this is written in ones and zeros. Ones and zeros is sometimes referred to as binary. It's a language that's referred to as binary. And bi because bi means two, right? So if you have a bicycle, it's a vehicle with two wheels. So binary only has two values, 0 and 1. Does anyone know how to read binary? Anyone know how to read binary? Well, by the end of this presentation, everyone in this gym is going to know how to read binary, because I'm going to teach you right now. Let me give you a couple of examples. Any ideas what 0, 1, 0, 1 means in binary? 0, 1, okay. SOS? Not quite, not quite. I can see how you got that though. What do you think? Hello? Yeah, not quite. It actually means 5. 0, 1, 0, 1 means 5. That's kind of weird, right? How about 1, 0, 0, 0? In normal human speak, that means 1,000. In binary, it does not mean 1,000. It actually means 8. And 1, 1, 0, 0 in binary? What do you think? 9? Not quite, not quite. You're off by 3. It actually means 12. So is that weird? That's a little weird, right? This is actually something that I address in the book. In the book, I have this scene where there's this bird, and he's kind of a weird bird. It's called a binary bird. He sees a 7-shaped earring that Hopper wears. Hopper wears these 7-shaped earrings because that's her jersey number. She's on the basketball team. And after the bird sees this 7-shaped earring, he does this. He opens 3 eyes. Hopper's kind of freaked out by it. She doesn't understand why this happens, so she asks her friend Eddie. And Eddie tells her, these birds are robots. Their eyes display binary numbers. And Hopper says, what are you talking about? So Eddie says, binary is how computers store numbers. Every computer has these, they're like switches that can be on or off. A number is stored as a sequence of on and off switches, or in the bird's case, open and closed eyes. And Hopper tells Annie, you make no sense. So Annie hands her 7 pens. Take these 7 pens. And they're going to play a game. We're actually going to play the same game right now in order to learn binary. Let's play a game. I'm going to draw the board right here. You always carry chalk and pennies in your pocket? Shh, I'm concentrating on my drawing. Here's the board that Annie draws. Now I've got 4 columns of boxes here. The first column has 8 boxes, then 4, then 2, and then 1. So here are the rules. Here are the rules for the game. I want you to fit all 7 of those pennies into these boxes, but there's a catch. After you're finished, every box has to be solution that we did for 7. And then she realizes 7 is equal to 0, 1, 1, 1, or if we're talking about switches, off, on, if we're talking about bird's eyes, closed, open, open, open. And that the bird indeed is displaying 7 with its eyes. So that's my area. Let's talk a little bit about the source code now. Like I told you before, the source code is usually written in an English-like language. That English-like language is often referred to as a coding language or a programming language. And there are tons of coding and programming languages out there. If you talk to any professional software developer, they'll most likely know at least a handful of them. The last one that came up on the screen, the one in red logo, is the very first programming language that I ever learned. I learned it when I was in 5th grade. This is what I looked like as a 5th grader. It was the 80s, so big hair was very popular back then. And I learned how to code on this computer right here. This is an Apple II. The cell phones that your parents have in their pockets are most likely about 1 billion times more powerful than the Apple II. But I still love the Apple II because this is the computer that I learned how to program on. It was during the summer after my 5th grade year. I started off the summer having a lot of fun. I spent all day in front of the TV. I watched a lot of reruns of cartoons. I watched Reading Rainbow, but I didn't read any books. And then my mom got sick of seeing me in front of that TV, so she signed me up for these summer enrichment classes. I wasn't very happy about it. She signed me up for 4 classes. I only remember one of them now. The one that I remember was an introductory computer programming class. It was an introductory coding class. Now, Logo is kind of a forgotten language. In terms of computers, it's seen as like this ancient language that almost nobody in America uses anymore. It was designed really to teach kids how to program, and nowadays, in America at least, nobody learns with Logo. People still do in the world though. In India, a lot of kids are still trained in programming by using Logo. The best part of Logo, the most endearing part, at least in my opinion, is this turtle. There's this turtle in Logo. It usually doesn't look like this. It usually looks like this, because graphics in the 80s just weren't very good. But in Logo, you can give this turtle commands and make the turtle run around the screen and draw stuff. This is what made me fall in love with programming, because I realized that you can use coding to make pictures. You can use coding to make art. I like Logo so much that I decided to use it in my book. So the language that Annie and Hopper and their friends learn is Logo. And I have this scene in the book where they actually find this robot turtle. I created a robot turtle character because I wanted to pay homage to the Logo language. Hopper and Annie experiment with the Logo turtle by giving it different commands, and we are going to do the exact same thing right now. You can actually still get Logo, even though it's old, even though it's kind of forgotten, you can still get a version of it for a modern computer. I'm going to show it to you in a second. You can get it for free. And what we're going to do now is I'm going to experiment with the same commands that Hopper and Annie use in the book. We're going to start with just 3 that are pretty easy. Forward, left, and right. These 3 commands do exactly what you expect them to do. They tell the turtle to move forward, to turn left, or to turn right. Now you have to follow each of these commands with a number of some kind. For forward, you follow it with a number that tells it the number of steps it has to take. So if you say 410, it'll take 10 steps. If you say 450, it'll take 50 steps. For left and right, you give it a number that represents an angle. You give it a small number like 5, it'll turn just a little bit, it'll do a small angle turn. If you give it a bigger number like 90, it's going to do a wider turn. So 90 is a direct turn to the left or to the right. Make sense? So let me instead of typing left, you type in LT, and it does the same thing. It's RT for right. So I'm going to start with the CS, which is a clear screen. It resets everything. And now watch this one line. You see repeat. 4, forward 100, left 90. And when I hit return, it creates a square. That makes sense? Okay, I'm going to give you one more line of code. This time I'm going to use 2 repeats in a single line. And I want you to see if you can figure out what it's going to do. Alright? So watch this. Repeat. 36. Repeat. 4. Forward 100. Left 90. Left 10. Any ideas what that's going to do? Any guesses? Any guesses? Go ahead. It's octagon, maybe? Anyone else? A turtle, maybe? A triangle. So it's repeat 36, repeat 4, and then those lines that we've been using before this. Any more guesses? One more guess? Go ahead in the back and yell. What is it? A car? If he had said star, you would be closer. Watch this. I'm going to hit return. Okay, let's see what this happens, what this does. You see what it did? What is that? Why did it do that? Why did it do that? What exactly is that? Go ahead. It doesn't seem like it makes any sense, right? Remember, repeat 4 created a square. I told it to repeat 36, that repeat 4. So this is actually 36 squares arranged in a circle. That's how I created that pattern. Make sense? 36 squares arranged in a circle. Now this is why I got into programming. I realized that you can create pretty complex designs with just a few lines of code. You can become a much more powerful artist by learning coding. And I think this is true of every profession. No matter what you do in life, if you learn how to code, you will become better at whatever it is you do. Nowadays, programming skills are used in law, they're used in medicine, and they're obviously used in the tech industry. Programming, coding, is really a ticket to the future. It's a ticket to whatever the future is for the profession that you choose. So I would encourage you, if you haven't thought of coding at all, I would encourage you to go and find an introductory programming class and give it a try. I think a lot of you are going to find that you really like it. So at this point, are there any questions that I can answer for you about anything? About the material that we just covered, about Avatar or Superman or anything else? There's a question that I wanted to ask about binary. Go ahead, but you can ask something else too. You don't have to ask about binary. You have a question? You have anything else? Anybody else? Yes. That is the exact question I wanted you to ask. Did you hear a question? Probably not. So her question was, notice on this chart, there's actually only 15 squares, right? So what happens if you go over 15? Like with this chart, the biggest number that you can represent is 15. The answer is, you can add more columns this way. So how big is the next column going to be? What do you think? What do you think? You gotta guess how big. 16. How'd you figure that out? That's right. Okay, so she figured out exactly. The next column, if you were to add another column here, it would be 16. And she realized that because every single column is actually twice as big as the one that came before, right? So you can go 16, and then you would add another column with 32, and then another one for 64. You can go as big as you want. Each of these columns represents, in computers, what's called a bit. Have you heard that term? And 8 of these bits together represents a byte. And about 1 million of the bytes together represents a megabyte. I'm sure you've heard of that. So that's actually what they're talking about. They're just talking about little things that we represent as columns. Go ahead. Okay, the question is, will I be able to see the Coders Book 2? Right now we're assigned to do 3 books. The first one just came out this month. The next one will be out in 2016, and the one after that will be out in 2017. I'm hoping to do 6. So right now my agent is talking about publisher about doing 6 of the books. Yes? Say it again. Okay, so the My favorite brand of purified water is probably the sun. The sun, you get that? Okay, any other questions? Go ahead. Okay, so her question is, what is my book, Eternal Smile, about? Eternal Smile. So some of my books, I do both the writing and the art. And some of my books, I only do the writing. Something else does the art. For Eternal Smile, I only do the writing. The art is done by a friend of mine named Derek Kim, who is absolutely amazing. He can change the style of his art at will. So what I came up for him to draw was basically 3 short stories in 3 different genres, so that he could take on 3 different